So there you go. Now, the big question is, how can we relate the periodic table to the electron structure or the electron configuration of an atom? Now, it turns out if you really understand the periodic table, you will be able to, one, draw the electron structure of the atom, two, predict a whole slew of properties in relation to of one element to another element. You can even predict if a chemical reaction will happen based purely on its properties. All right? Whether it does, that's another thing. Then you have to do the experiment. But let's start off with just understanding how the periodic table relates to the electron structure of the atom. All right, let's look at the very first element at the top. All right, in our periodic table, it may be in the middle, but usually it's drawn over here at the top left corner. The hydrogen, the proton number of the for hydrogen is 1. Oh, by the way, forgot. The periodic table is arranged by atomic or proton numbers. So you can actually just follow it by counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and you can go on and on and on and on and on. All right, so you can actually follow the periodic table in terms of its atomic or proton number. All right, okay, now let's get down to it. Hydrogen has 1 proton, so let's draw the nucleus of hydrogen, and hydrogen sits on the very first period. Each period equals to an energy level. Okay? So period 1, all elements in period 1 will have 1 energy level. All elements in period 2 will have 2 energy level. All elements in period 3 will have 3 energy level. Okay? So here we go. So let's look at hydrogen. It sits on the first period, so it has 1 energy level. So let's draw that 1 energy level. Zoom. Now, it is very important to note that this circle around the nucleus does not mean that the electron of hydrogen, or the electron is orbiting around the nucleus. It's not the case. This circle is a representation of energy level. It is very important to do that, to know that fact, that electrons do not orbit around the nucleus like how the Earth orbits around the sun. It in fact is just haywire, jumping all over the place, disappearing, reappearing somehow. All right, and that's the general behavior of electrons around the nucleus. All right, it's just behavior sporadically, it's behaving like a crazy dude. All right, around the nucleus. So, but in order for us to understand how the shape of atoms and how the electron is behaving, what the electrons and how the electrons are behaving around the nucleus, we have to simplify the model. So this is a very simplified model. All right. Okay. So here we go. Because the proton number of hydrogen is 1, we have 1 electron on the first energy level, all right? Or we can call these energy level shells, all right? So what about helium? Let's look at helium. Helium has an atomic number of 2. So it also sits on the first period. So that means helium will have 2 electrons. I should draw it like that. 2 electrons on that first energy level. So that's how it is. And remember, any elements on the second period should have 2 energy levels. The first energy level is going to look exactly like this. And the second energy level now should be encompassing the first energy level. That means the second energy level surrounds the first energy level. It's kind of like a Ferrero Rocher chocolate, a biscuit bite or whatever. I don't know the name of it. All right. So you have the outside layer and you have the inside layer. So it's kind of like that. So you have outside layer, inside layer. Now, let's look at lithium. Lithium has an atomic number or proton number of 3. So that means the first 2 electrons are inside the first energy level, right? And the third electron should sit right on the second energy level, okay? Or the second shell. Now, let's take a look. So now, how about any other elements on the second period? Well, let's look at carbon, okay? That's our favorite. Carbon has the proton number 6. 2 of its electrons are on the inside shell because it's 1 and 2, so 1 and 2. And what it leaves us is it has 4 more electrons on the outside shell. So that means carbon has 4 valence electrons. You remember valence electrons, right? It's been a while now, but we should remember that. And the way you draw it again is that the electrons should be as far away from each other as possible. All right. Now the reason why I didn't draw the first 2 as far away from each other as possible is because it's due to a concept that is beyond this curriculum, but it's based on a concept that 2 electrons fill a particular energy level. All right. Now each energy level, there are actually multiple. They may have multiple sub-energy levels, and each sub-energy level has a distinct shape. But we're not discussing the shape of the atom. We're just discussing the electron configuration of the atom. So this is what I'm doing. I'm using this model to describe the electron configuration, and I'm not using this model, the properties of the periodic table to describe the shape of the atom. All right. So don't get these 2 concepts confused. All right, so actually on the second period, there are actually, let's see, 4 different shapes, okay? All right, if you really want to look at it. We're not, again, I'm not going to say it. So 4 different shapes. So sub-energy level. So the first sub-energy level, the second sub-energy level, the third sub-energy level, the fourth sub-energy level, okay? So here we go. So we drew for that. This is the electron configuration of carbon. Now, we can use this concept to draw all kinds of electron configuration for many, any of the elements here when we know the exceptions. Now, the exceptions to the periodic table will not be covered at this level, but if you're interested, we can talk about it in class, all right? So, let's say if I want to draw the electron configuration for chlorine. Now, chlorine is on the 3rd period, so it should, in fact, have 3 shells. All right. Now, how many electrons will fill the first shell? Well, we have 1. The first shell will have hydrogens, have 2 elements, right? So the electrons should be right there in the first shell. On the second row shell, we have how many elements? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 electrons. And so we can put those 8 electrons in here. All right, so there you go. We have 8 electrons. Now, let's look at chlorine now. Chlorine comes in 1, 2, 3, 4, 5, 6, 7. So chlorine has 7 electrons on its outer shell, its valence shell. So its outer shell should have 7. So we usually draw it as 1, 2, 3, 4, 5, 6, 7. Okay? So there you go. That is how we relate the electron configuration to the periodic table.